Alright, this is a chapter 1 sample test, and some people wanted to have a key, and I want to do a video of some of the more complicated one here. So this will be kind of the key. I'll just go through it fairly quickly on the less complicated. And I've done some of these differently than I've done in the past, so I'll explain here as I go along. So the distance from A to B, of course the distance formula is the square root of the change in x squared plus the change in y squared. So, and I like to say from 4 to minus 6 on a graph, that goes back 10. That's negative 10. And from 3 to negative 2, that's back 5. And I have to add those and then take the square root. So 4 to negative 6, just make sure I'm doing that right. 4 to negative 6 and 3 to negative 2, yep. So I get a negative 10 squared is a positive 100, and a negative 5 quantity squared is plus 25, and so that would be good enough for that answer. You could reduce it to 5 square roots of 5. Find the midpoint. That's the average of the x's. So that's that's 4 plus a negative 6 divided by 2. That's the average of the x's for the x coordinate of the midpoint. And average of the y's, 3 plus a negative 2 divided by 2. So we get 4 plus negative 6 is negative 2 divided by 2 is negative 1. And 3 plus negative 2 is 1 divided by 2 is 1/2. Now on this one, C, find the coordinates of C if A is the midpoint. So let's kind of do a quick sketch. This is not going to be a real accurate graph, but A is at 4, 3. And B is at negative 6, negative 2. And it says find the coordinates of C if A is the midpoint of segment B to C. So C would have to be up here. Now we've already determined that this change in x was negative 10 going this way, so it's positive 10 going this way. And the change in from A to B in the y was negative 5, but if we're going the other way from B to A, that would be plus 5. And so we'd have to do another 10 and 5, or we could say we're going to go from B, which is negative 6, negative 2, to the middle, 4, 3, and then on to the next point. This goes up 10, so it'd be 14. This goes up 5, and so it'd be 8. And so C would have the coordinates 14, 8. Okay. Find the equation of the line in the slope-intercept form. And so we know that the slope is change in y over change in x. That's rise over run. And so the slope is the change in the y was negative 5. And the change in the x was negative 10. And a negative divided by a negative is a positive, and this is 1/2. So that's a smaller change on it. And that's going from B to A. We go up 1 and over 2, up 1 and over 2, and work our way, and we would get over to A, going from B to A. So that's the slope. So the equation would be y equals 1/2 x plus the y-intercept, which we use the letter b for, and if we don't know what b is, we can solve for it by putting in one of the points that it goes through. So avoiding the negatives, I'm going to put in 4 for the x, and I'm supposed to get 3 for the y. So 1/2 of times 4 is 2 plus b something. It's got to come out to be 3. So b would have to be subtract 2 from both sides, 1. And so the equation in the slope-intercept form is y equals 1/2 x plus 1. Okay, it says write it in general form. Now I can convert this to general form by and that's where it's ax plus by plus c equals 0 or equals c. And I can get that by just simply transforming this one. But if I made a mistake on this equation, I can just do it again. Let's see. This, if we know what we're doing here, this is excuse me. Have to get a cough drop, sorry. It's the change in y times x minus the change in x times y equals a constant. Going back up here to the first thing, the change in y was -5. Minus the change in x was -10. Then we figure out the constant by using a point. So we have negative and negatives, that's plus, just so you don't think that's 70. And I can use any point. I'll use the 4 and the 3. That's -20 plus 30. There's 10. So C has to be 10. Now we can check it by using the other point. -5 times -6 is 30. -2 times 10 is -20. 30 minus 20 is 10. So that is working. It's hitting both points. I could have used the reduced slope. I could have said 1x minus, that's the change in x, 2y equals a constant, and put in the 4 and the 3. 4 minus 6 is -2. That's a simplified form of it. And or I could have taken the original equation that we got here, the slope-intercept form, subtract half x from both sides, and I would have -1/2 x plus y equals 1. But the half is not an integer. I'd have to multiply it by something like 2 to make it a whole number. And I can multiply by -2 if I want to make that be a positive x's. If I multiply this side by -2, I have to multiply the other side by -2. -2 times -1/2 is 1x. -2 times the plus y is -2y equals -2, and you notice that's the same as this one. So on your take-home test, where you got lots of time, right, supposedly have lots of time, you can try it several ways and make sure you keep getting the right answers. Now if you did this one, if you notice, if you divide everything by -5, you will get the same answers here for these. Next one. I've put this on there, and there's different ways of doing it. I'm going to do it the way I've done it this year in the classes. Find all the coordinates on the x-axis that are 5 from A. A is 4, 3. Let's look up here. And we want to be 5 from it. So 5 is about, see, that's over 4, so 5 is that long. So if I drop it down, it's going to hit there. All the points 5 from A. We're going to make a circle. The equation of that circle is going to be x minus 4, because the x coordinate was 4. A is 4, 3. X minus 4 squared plus y minus 3 squared. And if we're going to have a circle, that's 5 is the radius, which is equal 25. There's the circle around 4, 3. And if we're going to be on the x-axis, did I say on the x-axis? Yes. On the x-axis, then we're going to find the x-intercepts by letting y be 0. So x minus 4 plus negative 3 squared is 25. Negative 3 squared is positive 9. So I'm going to subtract 9 from both sides, because that's a positive 9. And I get x minus 4 squared equals, because I've subtracted this positive 9 out by subtracting 9, equals 16. To get rid of the square, I take the square root and I get x minus 4 has to be square root of this side is just square is gone. Square root of that side, square root of 16 is either a 4 or negative 4. And so I get, add 4 to both sides, and I get x equals 8. X equals, add 4, 4, it's 0. So, sorry. It must go through the origin, x equals 0, or it goes through that x coordinate at 8 when y is 0. Sorry, I even have a cough drop. Okay, find the equation parallel. That would be, have to have the same A and B. I'm going to just use this one. You can use this one. Have to have the same slope. You would throw this out and find the new y-intercept. I'm going to use this form, which is x minus 2y equals, I'm going to throw the minus 2 out. But to be parallel, I got to keep the two parts to the same slope and put in 1 and 5. 1 minus 10 is negative 9. Perpendicular. So that's where you either flip this, having a hard time here, flip the slope and change it to negative, or swap the coefficients and change the sign. So I'm going to do this one just because you're not as familiar with it. So the 2 will go over to here, it'd be 2x, and I'll change the sign and put the 1 over here, make it 1y equals, figure out a new number, so it goes through minus 1, 2, so that's minus 2 plus 2 is 0. You could solve for y and see what it would look like if it was in a y equals mx plus b form. Okay, that's page 1. Page 2. Find all intercepts. So if I have x squared plus 5y equals negative 7, if I want to find the x-intercepts, I make y be 0. And if y is 0, 5 times 0 is 0. And so I'd have x squared equals negative 7. I'd take the square root and I'd have the square root of a negative. And you can't take the square root of a negative, so there are no x-intercepts. If I want y-intercepts, I make x be 0. And if x is 0, I get this, and so it says that if I solve this for y, because that's 0, I divide by 5 and I get y is negative 7/5. Okay, so I only have one intercept, so that's not a lot to graph a function with. But I know something about the symmetries. This equation is not going to care whether x is a positive number or a negative number. For the same value, like a positive 3 and a negative 3, it'll give me the same looking equation. So if it doesn't care where x is positive or negative, it's going to be the same looking on either side of the y-axis. So this has y-axis symmetry because x is squared. In other words, doesn't doesn't care whether x is positive or negative. Now, will it have x-axis symmetry? Sorry. This will care whether y is positive or negative. This will turn out to be different values, and so I'll change the equation so it does not have x-axis symmetry. Okay, so now I got to graph it. So if I got to graph it, I'm going to have to find more than just one point, because that's not going to help me. So I'm going to try to put numbers in for x to help me get more of a graph. Or maybe put numbers in for y. It doesn't really matter which. We know that it goes through 0, negative 7/5. What if we put in 1 for x? So then I would subtract 1. 1 squared would be 1. So I'd subtract 1, I get negative 8. And I divide by 5 and I get negative 8/5. And if I put in negative 1, I would get the same thing. If I put in negative 2 or plus 2, that would be 4. Subtract 4, that'd be negative 13 divided by 5. Negative 13/5. And so I've got some idea what this looks like. Let's see now what I have. So x is 0, y is plus or minus 7/5. If x is 1 or minus 1, it's negative 8/5. If x was 2 or negative 2, it's negative 5, 10, 13/5. And I can see that I'm starting to get a curve that looks like that, where this is 1 and 2 and 1 and 2, and the x-axis and the y-axis. Okay, determine the equation of a line perpendicular to x equal 2. What does x equal 2 look like? Well, x equals 1, x equal 2 right there, and y is 0. But x equal 2 is also right there when y equals 1 and y equals 2. And x equals 2 is every place right there. So this is the line x equal 2. So I need to make a line perpendicular to it, so that would have to go completely horizontal. And if it's going to hit -2, 5, it's going to have to be horizontal up here. And so what's an equation of a line that's like this? Well, if it's going horizontal, the x values are changing. X is 0, x is 1, x is 2, but the y values are all staying at 5, and so the equation would be y values are always 5 on the coordinates of the line.